Okay, here we are today. This is the Pythagorean Theorem. This is Unit 7, Lesson 1. So let's take a look and see what we got. Okay, the Pythagorean Theorem. Typically the vertices and sides of a right triangle are labeled like this. Notice that you got A, B, and C. C is always generally the 90-degree angle. Okay? Notice that what they did here is these small letters are the name of the segments that are across from the angles with the same lettering. Okay? So that helps you figure out what you're looking at every time. But notice that C will always be the hypotenuse, so that means that C always has to be the 90-degree angle. Okay, the relationship between the sides A, B, and C is known as the Pythagorean Theorem and is given by this particular formula, which is the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. So that means that you square each of the lengths of these legs, add those together, and that's going to be equal to the length of the hypotenuse squared. Okay, that's summarized algebraically as a squared plus b squared equals c squared. So given the lengths of any two sides of a right triangle, the third side you can find with this equation. So if you're given the two legs, you can find the hypotenuse. If you're given a hypotenuse and the leg, you can find the other leg. Alright, so example 1, find x. Okay, so x is up here as the hypotenuse, so this means we have the two legs. So in other words, we have a and b. So let's figure out what we got. So this gives us x squared, which is this thing up here substituted into our formula, is equal to 2 squared plus 5 squared. Okay, do the operation there, that gives you x is equal to the square root of 4 plus 25, which gives you x is equal to the square root of 29. So the decimal approximation of this is approximately 5.39. The absolute length of it is the square root of 29. So make sure you know what you're looking for. If they tell you to get the absolute length or the exact length is another way they say that, then you leave it as the radical, but you have to reduce the radical as well. Okay, example 2. This time they're missing this leg down here, so we have one leg and the hypotenuse, so they still want us to find x. So this time we have x squared plus 5 squared equals 10 squared, which gives us x squared is equal to 10 squared minus 5 squared. So once again, we have to take the square root of the result of this in order to find what x is. So that gives us the square root of 100 minus 25, which is the square root of 75, which approximates out decimally as 8.66. Alright, example 3. This time they gave us a trapezoid. Notice that this triangular section here, they're wanting to know what the length of this leg is. Okay? Actually, this is the hypotenuse of the right triangle because the 90-degree angle is right here. Okay? We know that this whole thing here is 11, this is 7. So this tells us that this part right here is actually 4. And we know that this is 5, so this leg is 5. So they've given us the two legs. We need to find the hypotenuse. So we plug it into our formula, and what we did here is we just summarized the information we just talked about with a triangle diagram so we know what we're looking at. This becomes x squared is equal to 5 squared plus 4 squared, which is x squared is equal to 25 plus 16. Take the square root of both sides, gives us x is equal to the square root of 41. The decimal approximation is x is equal to approximately 6.40. Okay. Example 4. They want to know what is the length of a diagonal of a rectangle with a length of 200 and a width of 100. So here's what we have. We have a rectangle that we drew ourselves. It's 200 long by 100 wide. So we're looking for the length of this, which is going to be the hypotenuse of a right triangle. Okay, so this gives us x squared is equal to 200 squared plus 100 squared. So x is equal to the square root of 40,000 plus 10,000. X then is equal to the square root of 50,000 when we combine. Take the square root of that, and the decimal approximation is 223.61. Okay, this should be basically a review for you, but if you have any questions, feel free to ask them before we start the lesson tomorrow, and I'll be more than glad to help you with it. Okay, if anybody has any questions, let us know. Thank you. We'll see you tomorrow. Goodbye.